Woohoo, we're recording. Yay! And today is very exciting because today is the first day I'm using a brand new setup, woohoo, to record because YouTube and I are having a moment. So we're taking some time reestablishing boundaries, and maybe my boundaries are going to be pretty thick with when it comes to YouTube. So let's go ahead and give this a try. Woohoo! We are in chapter 6, section 6. And at this point, you have learned a whack ton of different techniques for factoring polynomials. And so what we want to do is we want to take a break, review what's come before, and then see what we can do if all of the different types of polynomials kind of come at you at once. So it's going to be bing, bang, boom. It's going to be exciting. It's going to be so thrilling. It's going to be Godzilla versus Sharktopus kind of madness. So let's go over what the techniques are. The first thing to talk about is we're going to say that for most of this, all of this but the first step, the key to factoring is going to be to count the terms. But before you even worry about that, step number 1, always look for greatest common factors. Factor out anything that's common to all terms first. That's the very first thing you always want to do. Then count the terms. If there are 2 terms, then we've got 4 possibilities. A sum of squares cannot be factored in this class, wink, maybe in another class. The difference of squares, a squared minus b squared, equals the quantity a plus b times the quantity a minus b, woohoo. A sum of cubes and a difference of cubes. And remember, we talked about these two. We want to think about them together. So, of course, I set them up to print together, and of course, now they're printing all goofy style. But basically, a sum of cubes, a cubed plus b cubed, starts with a plus b, and a difference of cubes, a cubed minus b cubed, starts with a minus b. So we've got these 2 formulas, which are a little bit hard to remember, but easier when you remember how they're different, the different signs. Then we move on to 3 terms. Trial and error. I didn't write out a formula here because trial and error is basically just going through and looking at all the possibilities and picking one, the one that works. There's also the possibility that you could have a perfect square, so I reminded you of those formulas. Remember that a perfect square can also be factored using trial and error. Now, there are a couple of other methods we talk about. They are not methods which are easily written down using formulas, but they are, if I can find them, formulas that we have written down using cards. Here we go. And those are, and these are other videos, the X method. This is the really interesting, lots of colors, very exciting. And the AC method, which is the one where you multiply A times C and you look at B and then you look for your 2 secret numbers. And if you've seen the X method video, you know this also relies on this same technique. So these are kind of go together in that shortcut. And unfortunately, because they are a little bit on the complicated side, there's no way to just write out a formula. So you may just want to take a screenshot really quickly here, so you'll have these in the same set of notes. So that's for 3 terms. So 3 terms is usually, it's one of the harder ones because there are so many choices. So we're going to be working on those. And in fact, if you continue on to Algebra 2 and Algebra 3, we will continue to work on those. You will get extra techniques as you go along, but it mostly is going to depend on just practicing. The more you practice, the easier it'll get, I promise. Okay, step 4. If the polynomial has 4 terms, then we're going to do grouping. And again, grouping doesn't have a formula, it's a technique. And we will have some examples in here, so you'll be reminded about that. Step 5, keep going until you don't have any x's with powers. Now, this is, I wrote this out in English rather than in math. So x doesn't appear to a power. So in other words, there are just x's, not x squared, x cubed, x to the 4th. Of course, x is x to the first, so it is a power, but you know what I mean. There's no power written, so no x squared, so no x cubes. Or all the factors are prime. If all the factors are prime, then you're done. If you can't factor any of the pieces, then the whole thing is factored. And how do you check? You check by multiplying the whole thing out. So, shall we go ahead and get started? Yay! Yay! Okay, so this is your warning. I'm about to take this page away, so pause, screenshot if you like, or grab the notes. Okay, let's go to the next page. Woohoo! So the instructions here, very open-ended. Factor completely if possible. So it's always possible that the whole thing is prime. Unlikely, but possible. So with this first one, 10a squared x minus 40b squared x. The first thing you want to do is see if you see anything in common. Now the a squared and the b squared do look similar, and so that can be a little bit distracting, but since this is a squared and that's b squared, they're not actually, they're not something you can factor out. However, I do have an x in each term right there. I've got my x's there, and I've also got a 10 and a 40, so I can factor out a 10. So I'm going to factor out a 10x times something. And I'll remind you that you can just go immediately to this step, or what you could do is you could write each term with the 10 and the x separated out. So if I write 10a squared x with the 10x first, then I've got a squared. And then I've got 10x, and then what's left? Well, to get to 40, I have to multiply by 4, and then I also have the b squared. And then from this step, I factor out the 10x, and I've got 10x times the quantity a squared minus b squared. Notice that I didn't finish my parentheses there. Okay, so here we go. There's the 10x, there's the 10x. That was the GCF, the greatest common factor. So now the next question is, am I done? Well, so some people will ask, do I have to factor the 10? And the answer is no. In this, when we're factoring polynomials, we don't also factor the numbers, which is interesting. Like, shouldn't it be 5 times 2? It is possible to do that, but generally that is not what we're asking for. That will not actually help us go to the next step in a lot of problems. However, a squared minus b squared hopefully is kind of tickling some of your brain cells there, because a squared minus b squared is a difference of 2 squares. So I can actually factor the, my brain got excited and wanted to get ahead of itself. So this is 10x, and then a squared minus b squared, remember, factors as a plus b, a minus b. So notice in this problem, even though the x appeared to the first power, so we're done with the x's, the a's and the b's could still be factored. So we're working with more than one letter that could be considered a variable or an object that can be part of a factorable expression. So what do you think? I know I'm talking to a computer monitor. It's probably not going to answer me. If it does, then, that would be a more interesting situation, wouldn't it? I think it's great. Yeah? Yes, it makes perfect sense. Okay, let's keep going. Yay! Okay, here we go. Now, little tiny expressions can cause big, big ripples. So, what do I mean by that? Well, x to the 4th, which can be a bit intimidating, don't panic, but x to the 4th minus 81 has, in addition to bunny fur, 2 terms. And recall, if I can pull this out, two terms, we're looking for a sum of squares, a difference of squares, a sum of cubes, or a difference of cubes. I've got a difference here. So I know I'm either in difference of squares land or difference of cubes land. Now, difference of squares, I've got 2's as exponents. Difference of cubes, I've got 3's as exponents. But nothing says anything about 4's. So let me show you the trick. If you haven't run across one of these in the homework yet, let me show you. So I'll rewrite the problem, x to the 4th minus 81. Now what I'm going to do is I'm going to say I can see x to the 4th. I can look at it as x squared squared. Because 2 times 2 is 4. And then here I can look at this as 9 squared because 81 is 9 squared. And then I've got another difference of 2 squares. Woohoo! So remember how we do this. This factors into 2 factors. One is x squared plus 9, and the other is x squared minus 9. Because remember, it's whatever is squared, the thing that's in here goes right there and goes right there. And then the 9 goes right here and goes right there. And then we say, oh, thank goodness we're done. And then I say, but are we? And we have Sharktopus and Godzilla look at it and we go, Now, even though we started out with one two-term expression, we now have two two-term expressions. Oh, darn it. So let's look again. And this, let's see, can I fit this in? I can, just barely. X squared plus 9, there's nothing in common, so I can't factor anything out. And x squared plus 9 falls into the category of a squared plus b squared. It's a sum of 2 squares. This cannot be factored. And I say wink because starting in the next class, Algebra 2, Math 60, you will be able to factor it a little bit. And then as you go further, if you go further in math, we absolutely factor this. We factor it using a whole new system of numbers. So it's very cool. So for right now, we say it can't be factored. And that's a little tiny white lie. It's a good lie. So we're going to stick with it. Second factor right here, x squared minus 9. That's a difference of 2 squares. That's this guy right there. So let's see if we can rewrite it. I've got x squared plus 9, and then I've got, and I'm going to use brackets, x, the quantity squared, minus something squared. And I think, what squared gives me 9? You're right, it's 3. X squared plus 9 times, and then this difference of squares gives us 2 more factors, x plus 3, x minus 3. And now I can hear your brain cells itching. I can hear you asking half questions of your monitor. And unfortunately, because this is pre-recorded, and I'm not psychic, I can't answer you. However, I can point out that yes, if you're noticing that when we start with x to the 4th, we end up with 1, 2, and then this one, which should go to another 2, but we can't do it yet. So this would be 1, 2, 3, 4. That's interesting, isn't it? So when you look at the exponent, it kind of tells you how many factors they're going to be. And that is absolutely true. And the one problem, the reason we have only 3 here, is that this x squared plus 9 can't be factored yet. But as soon as we can factor it, this one will factor into 2 pieces, and then we'll have all 4. Life will be beautiful and perfect. Unfortunately, I'm going to end the video here because life is not beautiful and perfect. And my neighbor, who has been mowing his lawn for 3 hours now, has started mowing again. So the next video is going to have to wait a little bit. But hopefully I've given you enough to get started with, and then we will continue on in the next video. Woohoo! And we will answer the question, will my neighbor ever stop mowing his lawn? Will his lawn ever be short enough? Will we ever get to do any more math? Come back here, same bat time, same bat channel, and we will answer these questions and more. Math on, guys, math on.